So here we need to prove that cotangent of theta raised to the power of 4 plus cotangent of theta raised to the power of 2 thus must be equals to cosec theta raised to the power of 4 minus cosec theta raised to the power of 2. So let's begin from the left hand side. We can start from the left hand side or the right hand side. So we'll start from the left hand side. So here we have cotangent of theta raised to the power of 4 plus cotangent of theta squared. Now if we take cotangent of theta squared as the common factor, then this will get multiplied to cotangent squared theta plus 1. Now we're going to use an identity. So we know that sine squared theta plus cosine squared theta, this value is equals to 1. Now if we divide each terms on both sides with sine squared theta, then we're going to get 1 plus so cosine over sine. So let's first write it down. Cosine squared theta over sine squared theta. That will be equals to 1 over sine squared theta. So we have 1 plus. So this ratio cosine over sine, that is a cotangent function. So we have cotangent squared theta. That's equals to 1 over sine squared theta. And we know that the cosecant function is the reciprocal of the sine function. So we are going to get cosecant squared theta. That means we are going to use this particular identity here. And we can rewrite cotangent squared theta within the parentheses and replace it with cosecant squared theta. Now we can also convert this cotangent squared theta to cosecant squared theta. All we have to do is we can rewrite it as cosecant squared theta minus 1 multiplied to cosecant squared theta. Now let's distribute cosecant squared theta with the two terms within the parentheses. So we have cosecant theta raised to the power of 4 minus cosecant squared theta, and this is going to be the expression on the right hand side. So we have proved this, and if we want to start from the right hand side, so let's do from the right hand side. We have cosecant theta raised to the power of 4 minus cosecant squared theta. So what we'll do, we'll take cosecant squared theta as the common factor. So this will get multiplied to cosecant squared theta minus 1. So if we use this identity cosecant squared theta minus 1, that means this will get replaced with cotangent squared theta. Now cosecant squared theta, so that will be replaced with 1 plus cotangent squared theta. So we have 1 plus cotangent squared theta whole multiplied to cotangent squared theta. So we can finally get cotangent squared theta plus cotangent theta raised to the power of 4, and this will be the expression on the left hand side. So either way which we start with, we will get the expression on the other side. So this proves this given trigonometric equation.